G'day guys, we are here today to talk about some of the pracs that we're going to do in our next lesson where we're investigating mineral properties. Minerals are the things that rocks are made up of. It's a little bit tricky, so come in here close and I'll show you what I mean. For example, have a look at this rock here. This is a rock. It's made up of different minerals. You can see in it there's bits that look like they're clear, there's bits that look like they're white, there's bits that look like they're grey, there's bits that look like they're black. Every one of those bits is a different colour and a different appearance because they're all different minerals. So that's one example of a rock. Actually, have a look at the background there. This is laminate, the background of the table, but it's made to look like granite, which is what this is as well. So all the different flecks there are meant to represent different minerals. This rock here doesn't actually have different minerals. It actually is made up of different rocks all glued together. So obviously that's a sedimentary rock, but you can see it's made up of lots of bits joined together. This one here is less obvious, but you can see really clearly we've got the greeny colour here, which is a copper ore, and the dark colour there, which is a type of iron ore. Two clearly different minerals. That makes it a rock. If it's got more than one mineral, it's a rock. Okay, cool. So what we're going to do is we are going to have a look at some of the tests that we're going to do to identify minerals. So the first one is colour. Colour's easy. Colour, you look at it and say, all right, it's this colour or it's that colour. While it's easy, it's also probably the least useful of all the different properties of minerals, because you can get some minerals that come in a really big range of colour, and quartz is a great example of that. Quartz can come in green, yellow, even purples, clear, dark, light. It's all over the shop. So colour's not particularly useful, but there are some elements that it is good for, so they do include it. The next one we are going to look at is luster. Now, if you want to zoom in here again, please. This sample here, this is a mineral called bauxite. Now, I'm just going to move it in the light. This is best done in sunlight, but anyway, we'll give it a go. As I move that compared to my eye, I can't see light shining off that at all. It's really dull, flat. It looks like clay. Something like that we would say has an earthy luster. Let's have a look at this thing here. Now, obviously it's got a gold colour, but that one there is very shiny. If it's shiny, it can be, I would class that one as metallic. That's got a metallic luster. Actually, here's another one probably with a metallic luster, a different mineral. And here's one over here that's also shiny, but it's not metallic. This one here looks like it's glass. So that's the other one you would say is a glassy luster. If it's shiny, it's either glassy or metallic. There are some other categories, but they're the ones we're going to stick with. All right, streak is the next one that I wanted to talk about. Now, streak is actually a colour description, but it's also very, very handy. It's more reliable than the colour description of the mineral. For example, this mineral here looks like gold, and in fact, in years past, lots of old timers have found these and have been mistaken and run off thinking they've struck gold. But the thing that tells you it isn't gold is if I slide it along a white ceramic tile, that colour is a dark grey. Now, real gold, if you do that with real gold, actually gives you a yellow streak. So the fact that that streak is not yellow tells me that that is not gold. So streak is actually the colour of the powdered mineral sample. Streak. Okay, the next one we are going to, oh, by the way, I meant to say, with streak, if you're dealing with a mineral that is harder than the ceramic tile, then you won't get a streak. Example here is quartz. If I run the quartz down the tile, I don't get any streak. What I do, in fact, is put a big scratch in my tile. So if you do the test with the mineral and it doesn't leave a streak, it means usually that your mineral is harder than the tile. Okay, the next one I wanted to talk about is hardness. Now, let's have a look at these kits here. Do you want to just zoom in on these for me, please, camera person? And what we've got are these Mohs hardness kits. Now, these are minerals that we use to compare the hardness. Over inside the lid, it lists them all. So number one on our list is talc. And here's number one. Where are we? Number one. Oh, this has been mixed up a bit. That's number one there. So that is a piece of talc. It's very, very soft. Talc is like chalk on with the old blackboards. You rub it on stuff, it gets scratched and leaves a trail on it. And then it goes up. Number two is gypsum, and so on through the list. The very highest one is diamond, which is number 10 on the scale, but for some reason they didn't chuck pieces of diamond in these kits for you to use. The hardest one in these kits is number 9, which is corundum, this one here. Corundum is a similar material to what gemstones like sapphires and rubies are made out of. These aren't sapphires and rubies, they're not valuable, but they are very, very hard. They will scratch almost anything. The way to test with hardness is you get your mineral sample and you test it, for example, this one here, that's a number 3. So I'll use a black and white one, it's a bit more obvious. If I rub them together, that's obviously, there's no scratch on there, but this scratched off onto it. So this is harder than a 3 because this was scratched. If I go up to, say, a 6, and I rub a line, and now this time I can't quite tell which one was scratched by which. You sometimes need to swap them around and rub the surface with your hand. Actually, I can tell that this is softer than that because the black colour of this came off on the 6. So that tells me that this is softer than the 6. So it's somewhere between the 3 and the 6. So I can, let's say for example it was harder than the 5, but softer than the 6, I'd say it has a hardness of 5.5. So that's how we do that test. The last test for us to do is a test on, is a calculation actually. We need to do a calculation for density. Density over here, density is a measure of how heavy something is for its size. Some of these minerals, for example, this one I'm feeling here, and this other sparkly, nice sparkly one, these have got a lot of metal in them, and for their size, they're quite heavy. Some of these other ones are really quite light for their size. Now, the description we're after for that is density, and to calculate density, we need 2 numbers. One is mass. Mass is really easy. You throw it on the electronic scales, and you wait for it to 0, and you write that down. That's its mass. The other one we need is its volume. Now, to calculate volume, we're going to use these things which we call displacement cans. And they're just a can with a spout. And we fill it up, and the water drains out the hole and drains out and dribbles and dribbles and dribbles until the top of the water is at the bottom of the hole. Now, let's say that's finished, and for the interest of the camera, we'll get on with it now. In order to measure the displacement, measure the volume, is we're going to displace the water. I'm going to lower this into the water, and the exact volume of this mineral sample will be measured by working out how much water comes out. By displacement, in other words. Now we need to let that dribble away. Let it dribble, let it dribble, let it go until it stops dribbling, and then you measure the volume. Once you've got the volume measurement, it's simply a case of density is the mass divided by the volume, and that will give you the density of your mineral. Good luck.